Today we're going to do a sampling method foldable. So start with getting a manila folder, and number one, you're going to cut the tab off just right down here at the end. Then open the folder completely and fold the ends together in the center. So it will look like this. Then you're going to cut 8 windows into this particular folder. So you'll have 4 on the left and 4 on the right. And your finished product will have 8 flaps. Today you'll need to make sure before you view this video that you have glue, colored fine pens, markers, scissors, clip art sheet, and folder. The clip art sheet I have attached to this video that you can get as well. You can also draw the things, but at the same time, it's a little bit easier if you use my clip art. Okay, so on your 8 tabs that you have, or flaps that you have done, this is what you're going to title it. I won't read it to you. I'll let you pause the video if you would like to. All right, so for the first one, inside the SRS flap. The SRS flap is the simple random sample flap. This one right here is where we're going to start. The dot here represents the fold. You're gonna glue this picture here to the left, and then in blue I have defined it, and then in pink I have given you an example. So first of all, in blue it says each person in each group of size N has an equal chance of being chosen. What that means is there's 12 people in this classroom or in this room, and every single person has an equal opportunity of being chosen. Basically, I would take their numbers and put them in a hat or shake them up or something to that degree, or I would use a calculator to do what's called a rand INT that I'm going to demonstrate in a second, or use a random table of digits and show that way as well. That means each person would be a chance of being chosen. Well, if you notice, I have 4 people. So in this particular example, 12 people are numbered using a calculator, and each person of size 4, because I'm choosing 4, each person and each group of size 4 has an equal chance of being chosen. So number 2, 5, 8, and 10 also could be 2, 5, 8, and 12, 2, 5, 8, and 3, 2, 5, 8, and 6, and so forth and so on. Or not even those, 2, 7, 11, and 12. Any 4 people should have an equal opportunity of being chosen, and that means that is what SRS is. SRS is the only one that has an equal opportunity of being chosen. Okay, the next, let me show you. Let's get to my CAS. Okay, so go ahead and open up your calculator, and on your calculator you're going to find here, menu, and you're going to go into probability, and you're going to go into random, and you're going to go into INT. So if I wanted to choose 4 people, I could put 1, 12. The first number is the first number that I want, the lowest number. The last number is the last number I want, and rand INT means random integer, and it gives me a random integer. I'm just hitting enter, and every single time I hit enter, it gives me a new person. So in the example we had, the first one's 12, then 11, then 2. Another way to do this is to rand INT 1, 12, 4. 4 means that's going to give me 4 numbers. So sometimes it repeats it, sometimes it gives separate, so you can see this is 12, 4, 4, 2. And if I wanted to choose 4 people and it gave me 12, 4, 4, 2, then I would hit it again, and I would just use 12, 4, 2, and then 1. So that's how you do it on the calculator. Again, let me go over that steps, and it's going to be menu, and you're going to go into probability, and you're going to go from there to random and then int. Or you can type literally rand INT parentheses, etc. All right, so that's the calculator method. Flip inside stratified random sample. Now stratified random sample, go ahead and glue this particular graphic. I went ahead and labeled the graphic. I numbered the people 1 through 14 for each one of them. But what stratified is number one, you split the populations into stratas. Those are homogeneous groups. Homogeneous groups are members in the group have a similar characteristic. So for instance, in the group that I have here, the similar characteristic is their grade level. I have a group of freshmen, a group of sophomores, a group of juniors, and a group of seniors. Those are 4 stratas that are homogeneous because they have something similar in the group. Then you're going to perform an SRS. What's an SRS? Where I choose randomly, like I just showed you, the rand INT, of each strata. So from our example, I split each populations of Dawson High School into 4 stratas: freshmen, sophomore, junior, seniors. I gave all the numbers in the strata, all the people numbers in the strata, and I randomly chose with technology or random digit table 2 people from each group. So when I did it, I got number 3 and 8 freshmen. For sophomores, I got 4 and 11. For juniors, I got 1 and 6. And for seniors, I got 4 and 14. Those 8 people are the people in my sample. And those people randomly represent the entire population of Dawson High School. Now notice here to the left in green, each person or group does not have an equal chance of being chosen. While freshmen are being chosen, sophomores, juniors, and seniors have no chance of being chosen. And the only people that can be chosen are freshmen. And same thing, if I have a group of 8, I should have the possibility to have all 8 of those freshmen, or 3 freshmen and maybe 5 sophomores, or whatever. We need every single type of group for it to have an equal opportunity of being chosen. But strata does not, and that's why if you noticed at the very beginning, I had a not equal to on strata. The next one is systematic, and systematic is when you randomly choose a starting point and you systematically count up the same number each time, and those people are the people in your sample. So for our example, I randomly chose a starting point, and in my instance, I chose 1, the first person, a random number between 1 and whenever I wanted to start, and then systematically count up every third person. This would be a really great thing to do if you were doing, maybe you're going to the Astros, right? And there's lots and lots of fans, thousands of people. So you wanted to get a good representation of them. So you said, I'm going to randomly start at the 50th fan, and I'm going to go up by 10 people. So the 50th fan is going to be, that enters the gates, going to be the first person you interview or survey, and then every 10th person after that you're going to interview. So that would be a really good opportunity for there. Again, same thing in green, each person does not have an equal chance of being chosen, because once I've chosen that first person, the second and third person do not have any chance at all of being chosen, and every third person has a 100% chance of being chosen. So each person does not have an equal chance. Okay, inside of cluster, we've got a cake. And I have gone ahead, and I want you guys to go ahead and color that cake because it's just white right now, and color it as whatever you want to. I have strawberry icing, chocolate cake, and vanilla cake. Whatever I want 3 different types, because cluster is when you're in heterogeneous groups where they're different. Each small group looks like the population. For instance, this piece of cake here, this slice looks identical to what's in the entire cake. And if I ate this slice of cake, I would have the same idea of what my population, aka in this way, my cake, would taste like. So you first of all group them into little slices of cake. Then you number all the groups and do an SRS to choose N groups, N meaning how many ever you want. Then your sample is all of those people or objects or whatever chosen in each cluster. So here's an example down here. I want to split all students. Let's say I have all senior level math courses. And these are the senior level math teachers: Myers, Fowler, Brown, Paul, Bailey, and Moses. So the first thing you're going to do is split the students into heterogeneous groups of senior math classes. Second, number each cluster. 1, 2, 3, 4, 5, 6. And then finally, I'm going to choose 2 of them just because I decided that's how many I want. and I chose 4 and 3. So all the students in Paul's class and Brown's class are in the sample. Those are the ones in my survey. Again, each person to the left of this part up here, each person does not have an equal chance of being chosen. Once Brown's and Paul's are chosen, the other students have 0 chance of being chosen. Plus, student groups do not have the ability to have any combinations. For instance, Myers, if you're in Myers' class, the only people in your group are going to be Myers students. You can't cross over to any other groups. Let's go into Census. Census, inside Census, you're just going to write entire population. And this is only good for small populations because clearly if you wanted information about the state of Texas, you would not use Census because there's too many people in the state of Texas to ask every single person what you want to ask them. Inside a multi-stage, this does one sampling method and then another. For example, SRS to pick 5 states, strata by county, 500 representative from each county, and then cluster group by city, randomly choose 2 cities from each county. I'm using a bunch of different methods. That would be multi-stage. Okay, let's go ahead and at the top and inside poor sampling techniques. Poor sampling techniques. Go ahead and glue this one here. You see the little girl raising her hand, but the boys are sitting there not really saying anything because why is she volunteering? Because she knows the answer. But in a volunteer response survey, we say only those who feel passionately about the answer volunteer. It creates a bias in the direction of the passionate. So for an example, if you had just had maybe a bad breakup because your boyfriend or girlfriend just cheated on you and you're a teenager and maybe this has happened to you a few times or, and then you see a Twitter poll that comes up, do you think teens are faithful to whom they are dating? Well, boom, right away, you are really upset over just what happened to you. So you are going to answer this Twitter poll. So you won't, if you've never dated before or never had any bad experience with dating, then you typically won't answer the Twitter poll. You're just whatever. And so what happens is this creates bias in the direction of the passionate and it leaves out the entire population, most of the population. So we don't know what the entire population believes. And that's our goal, is to get to see what the entire population that we're doing the sample is from. We are trying to find out what they actually believe. Convenient sample. Convenient sample here on the right is where you survey what is convenient for you, what's easy for you. And you leave out most of the population in doing this. And in doing so, like this one, this researcher above only asked to survey the people close to him. As you can see, he's missing maybe the purple people are a different race or gender or ethnicity or something, but they're completely left out of this survey. And the researcher, then the people that are close to the researcher, they might all be in a friend group and they might all believe the same thing. And so again, you are leaving out what the entire population believes. Let's look at types of bias. There are 3 types of bias we're going to go over. One is response, one is non-response, and the other is under coverage. So with response, there's 2 types of response bias. Let's look at the one at the left. You see this example. Who do you think is more fantastically wonderful, Barack Obama or Michelle Obama? Well, if you don't like either Obama, Mr. or Mr. Obama, if you don't like either one of them, it doesn't give you the opportunity to answer truthfully because you can't say, well, that wasn't a choice. I don't like either of them. That's not a choice. Also, you're influenced by the wording of this question in the way that they're saying fantastically. Well, this interviewer seems to really like Mr. and Mrs. Obama. So you are led by the wording to say, yes, I like them both. Maybe I like Barack better than Michelle or Michelle better than Barack or whatever. So the wording, it's poorly worded and it misleads the answers, which means it misleads your responses to what the truth is. And our whole point of surveying is to get the truth. All right. This teacher here in the second example says, class, do you get it? And the student says, yes, when they're actually thinking, And that's response bias. They answer the question, but they're influenced by the interviewer or something in the room or some aspect of it. So they're answering, but not truthfully. Or you see this other student with his head on the desk. He does not answer, and that is called non-response bias. The student does not answer either because they cannot answer or they will not answer. And the third type of bias we're going to talk about is undercoverage. Undercoverage is where a group is left out of the sample that's represented by the population, that the sample is representing the population. For example, a question as asked, are you for or against abortion? But it's done in a telephone survey and they only call people Sunday morning. Well, Sunday morning, a lot of people go to church and therefore there'd be undercoverage for those that attend church on Sunday morning. All right, that is the end of the types of bias and your foldable. Good luck and have fun with this.